Polynomial and synthetic division. Suppose you're given the graph of f of x equals 6x cubed minus 19x squared plus 16x minus 4. Based on the graph, what are the zeros? So the zeros are the x-intercepts. So if you look at the graph, you can see that the graph crosses the x-intercept at these points here and at this point here. So the zeros are 1/2, 2/3, and 2. And as you can see, you write it as x-intercepts as 1/2 0, 2/3 0, and 2 0. Now, so a possible factor, if 2, for example, is an x-intercept, then a possible factor would be x minus 2. Because if you set x minus 2 equals 0, you would get that 0 or that x-intercept to 0. So x minus 2 is a possible factor of this function. We can use this information to break down this function to algebraically get the other factors. Now, we can use something called polynomial long division. So here we have x minus 2. We look at the x here. We determine what times this x will give us 6x cubed. What times x is 6x cubed? Or you can look at it as divide that first term 6x cubed by x. And what you'll get is you'll cancel out one of these x's here. You get 6x squared. So this would be 6x squared. We will put it above its like term. What I mean by like term, negative 19x squared. These are like terms because they both have x squared on it. And then just like long division from elementary school, you will multiply this times your divisor over here. Multiply all of it. So 6x squared times x minus 2 is 6x cubed minus 12x squared. And just like long division from elementary school, you subtract it. But in this case, we say change the signs. So we are technically multiplying -1 through the entire polynomial here. So we put negative here and change that negative sign here to a positive sign. This will cancel. And then now we have negative 19x squared plus 12x squared. That will give us negative 7x squared. And we always bring down one term at a time. And we start over. We determine what times x will give us this negative 7x squared. Or if you want to look at it the other way, you are dividing negative 7x squared by x. What will you get if you divided negative 7x squared by x? You will get negative 7x. All right, so now again, we're going to multiply this times the entire divisor, not just the one term, the entire divisor. So negative 7x times x minus 2, and you might want to write it down as negative 7 times x minus 2 like that, and distribute, you will get negative 7x squared plus 14x. And then again, like long division, we subtract. In this case, we change the sign. So we're going to make that positive, that negative a positive, and this positive a negative. That cancels, and we get 2x here. Now it's time to bring down that last term and start back over. What times x is 2x? Well, only 2. So we're going to put positive 2 up here, multiply that 2 times the entire divisor to get 2x minus 4. And then we're going to change the signs. That becomes negative and positive. We get 0. So what does this mean? For long division, we can conclude that this original function here, or it's right in here, this is the original function here, can be broken down to x minus 2 right here times this 6x squared minus 7x plus 2. That's what we can break that down to. Now, our goal is to break it down into all linear factors. So, for example, this factor right here is linear because it's x minus 2, and you see it's you have a x to the first power here. It's a linear factor. However, this factor right here is quadratic. So we know how to break down quadratics either by factoring or some other method. So if this is factorable, for example, using the AC method, let's use it. So if we look at 6x squared minus 7x plus 2, if we use the AC method, we'll multiply 6 times 2 to give us 12 and break down 12 to 1 times 12, 2 times 6, 3 times 4, and decide what will work so that when we add the one of these pairs, we get negative 7. Like so, if we make that a negative and that a negative, that'll give us negative 7x, but when we multiply it, we get the positive 12 that we want. So it has to work both in both directions. You have to be able to multiply it to get the AC, and the AC is the 12. You multiplying ax squared plus bx plus c, you multiplying the a and the c together, and that's the 12. But when you add that, you're getting the b. And it has to work in both ways, right? For the pair to work. So only one set of numbers will work. All right, so we have 6x squared. Then we're going to put the negative 3 and then but negative 3x because we need a negative 7x, right? We need this to add up to negative 7x. So we got to put an x on it, or it won't be equivalent to the original quadratic. Now, since we have 4 terms, that should trigger factor by grouping. So we're going to take a 3x out times 2x minus 1. We're going to take a negative 2 out times 2x minus 1 because we wanted these two factors to be identical. Therefore, our factors are 2x minus 1 times 3x minus 2, or vice versa, 3x minus 2 times 2x minus 1. All right, so now we have all linear factors. That's what we wanted. We have factored this function 6x cubed minus 19x squared plus 16x minus 4. We have factored it completely using the polynomial long division and the AC method to break it down completely. So at this point, technically, you can just set all of those to 0, but I wanted just to show you quickly that in your previous algebra class, you've seen these type of problems written, division written this way, where you put that function over x minus 2, and then you were told to factor and cancel common factors. So I don't know if y'all remember that, but just to show you that this is also considered to be a type of algebra problem where you are dividing polynomials. So I know you recall canceling out factors at some point, and then you write what's left over in the problem. All right. Now we're going to move on to what is the relationship between the factors and the graph of the polynomial. Well, if we set all of these factors to 0 again, because we factored everything completely right here, if we set them all to 0, then you begin to see that we will get those factors up here: 1/2, 2/3, and 2, right? You see it up there. So you add 2 here, you get that 2. Add 1, you get 2x equals 1 divided by 2. X equals 1/2. And then you add 2 here, you get 3x equals 2 divided by 3. X equals 2/3. So the relationship between the factors, obviously, is that it produces the zeros, which also is the same as the x-intercepts, which are the points at which the graph crosses the x-axis. Note that 2x minus 1 and x minus 1/2 are equivalent factors because they both yield the same zero. So, for example, if we set x minus 1/2 to 0, you normally don't see the fractions like that. As a factor, but you can solve that by getting rid of the fraction by multiplying both sides by that denominator, right? And then you will see it's equivalent to 2x minus 1 equals 0. They yield the same 0 1/2 right here. So they are equivalent factors. Although it's conventional not to write a factor out with fractions. There's a nice shortcut for long division of polynomials by divisors of the form x minus k. This shortcut is called synthetic division. Synthetic division. So let's use synthetic division, and anytime your divisor is x to the first power, you can, well, your degree is 1 for your divisor, we can use synthetic division. And in this case, we got x to the first power, so we can use synthetic division. The nice thing about synthetic division is that you're only using coefficients and constants rather than coefficients, constants, and variables. So the first thing you do, you're going to draw like a little half box. This is going to be your K. And what is K? K is that number, see, it has X minus K, X minus K. So if I put X minus K here, what is the K really? Well, the K is the 2, right? If it's x minus k, there's already a minus there, so the k is just a 2. And another way I say it is opposite of what you see. So you see a negative 2 here, but k is opposite of that. So it will be positive 2, positive 2 here. And then across here, you're going to write down the coefficients 6, negative 19, 16, and the constant negative 4. So only the coefficients and the constant will go in synthetic division. So again, 6, 6, negative 19, 16, and negative 4. And then we draw a line. Give you a little space in between the number and the line. We always drop down the first number, 6. Then we're going to multiply whatever we drop down here times the number in the box. That gives us 6 times 2 is 12. We put that number here. We always add the numbers in the column. So negative 19 plus 12 is negative 7. Then again, we multiply the number we just dropped down times the number in the little half box. That's negative 14. We put that number here. Again, we add the numbers in the column. So that's 2. Then whatever we drop down here, we multiply times the number in the little half box. That gives us 4. And then we add what we have in that column there. That gives us 0. So that last number represents the remainder. Now, if you notice from the long division, our remainder, we did have a 0 remainder here. So that represents that number. But notice our answer lies, or it looks very similar to what we have here, 6x squared minus 7x plus 2. Why is it squared here? Well, notice we were dividing this cubic function by x, right? So if you divide a cube, x to the third by x, then your degree will drop 1 degree lower, right? So anytime you are writing the final answer to your synthetic division problem, know that this will be 1 degree lower than the original function. So we started with a cubic function. This will be 6x squared x squared is 2 is one number lower than 3. So 6x squared, and then we just write everything down in descending order. So what comes after x squared? X, and then that's our constant. So notice this is the same answer as synthetic division, right? All the way up here. All right, so synthetic division is intended to be faster once you get the hang of the process of synthetic division. And again, you can use it when your divisor is of the form x minus k. Here's an example long division example showing you the components of polynomial long division. Over here you have your divisor, and then your answer is called your quotient, and then your function that you're dividing by is your dividend, and then of course what's remaining down here is your remainder. Now, how do you write the answer when there is a remainder? There is a special way you have to write it. You write it as the quotient plus remainder over divisor. So the quotient here is x plus 2. You always put a plus sign in between the quotient and the remainder and divisor. So the remainder is 3 divided by the divisor x plus 1. So this is how you write the answer if you have a remainder. If you don't have a remainder, for example, if there was no remainder here, the answer would just be x plus 2. All right, now what if, so as you can see, we have this answer right here. This is the answer for x squared, dividing x squared plus 3x plus 5 over x plus 1. Again, I told you this is the same way you could write it. Write this. These are equivalent to each other, just written a different way. Now, what if I said solve for x squared plus 3x plus 5? I only want x squared plus 3x plus 5 on this side. I don't want x plus 1 on the left side. So what would you do? You will multiply both sides by x plus 1 to get rid of it. What will happen? That x plus 1 right here will cancel on the left. This is the left side, left hand side over here. So you get this on the left hand side. But what would be on the right hand side? What would be on the right hand side? Well, you have to multiply x plus 1 times x plus 2. So x plus 1 times x plus 2. Just leave it like that. And then you will multiply x plus 1 times 3 over x plus 1. All right, so I treated that like that went together. So I just wrote x plus 1 times x plus 2. And then if you multiply x plus 1 times 3 over x plus 1, the x plus 1's cancel. This is known as the division algorithm. The division algorithm. So if f of x and d of x are polynomials such that d of x cannot equal 0 and the degree of d of x is less than or equal to the degree of f of x, there exist unique polynomials q of x and r of x such that f of x, which is your dividend, so notice this was our dividend right here, x squared plus 3x plus 5. This is our dividend, f of x right here, equals. And then it says divisor is our d of x. Divisor. What was our divisor? Our divisor was x plus 1. So that's d of x right here. Times q of x is our quotient. What was our quotient? Our quotient was x plus 2. Q of x. And then it says plus r of x. Our remainder was 3. So this is known as the division algorithm. Now, let's divide x cubed minus 1 by x minus 1 for more practice. We're going to first go over long division and then synthetic division. What I haven't discussed yet is the fact that if you are missing terms, then you need placeholders. Missing terms need placeholders. So we are missing a couple of terms here. We have x cubed, but we are missing x squared, and we are missing x. So what we're going to do in this place is put placeholders 0 times x squared plus 0 times x in its place. So even if the divisor was missing terms, you will also use this technique using placeholders. It just doesn't work out well if you don't use a placeholder. So let's use long division first. So that's x minus 1 divided into x cubed. And again, we're using placeholders, and I'm just putting this in a different color to emphasize you need those placeholders in there. So x times what is x cubed? That's x squared. And then we're going to multiply x squared times the entire divisor, which gives us x cubed minus x squared. And then we're going to change our signs to minus plus. That cancels as it should. But this is 0x squared plus 1x squared. And this 0x squared is obviously 0, like it doesn't exist, correct? Because it doesn't. So we are going to bring down our 1x squared. All right, and then bring down one term at a time and start back over. So really, what times x over here is x squared. So that is x, positive x, times our entire divisor over here. So start it back over, x squared minus 1x. Then you're going to change your signs, minus plus, that cancels as it should. We have 1x, and then we bring down minus 1. Then we start over. X times what is x? X times what is x? All right, so notice our answer, our quotient is going down in descending order. So we notice we are missing a term, a constant here. So that's 1 times that. So that's x minus 1. And then we are going to change signs, and we have a 0 remainder. So what does it mean? It means that x squared plus, well, write it this way, x cubed minus 1 is equal to, right? It is equal to x minus 1 times x squared plus x plus 1. And you can't break that down. This is a quadratic or a trinomial, but it's not factorable, so we can't break that down anymore. So x cubed minus 1 is equivalent to x minus 1 times x squared plus x plus 1. So if you multiply all this out and add it all up, believe it or not, it's only x cubed minus 1. Now, let's try synthetic division. So if we try synthetic division again, we are going to put k in this box. And what is k? It's opposite of what you see here. So that's positive 1. And then we're going to use our coefficients and our constants in here. What are our coefficients and constants? That's 1, 0, 0, negative 1. All right, in synthetic division, you're always going to bring down the first number 1. You're going to multiply. You get 1. You're going to add. You get 1. You're going to multiply. You get 1. You're going to add. You get 1. You're going to multiply. You get 1. And you're going to add. You get 0. That last number represents the remainder. So the answer lies in this part right here. Now we started out with a wet degree polynomial. It is a third degree polynomial or cubic function, x cubed minus 1. Therefore, in synthetic division, our answer will be 1 degree less. So it'll be 1x squared plus 1x plus 1. So notice this is the same answer as this, but it was a little faster than doing long division.